Hello, hello students. In this class, we will see the triangles chapter, last exercise, 11, 12, 13 questions and their solutions. Okay. These are based on the last chapter is based on the similarity criteria, three criteria. Just recap it. AA criteria, SSS criteria, SAS means if in two triangles, all the three angles are equal means they are similar. If all the three sides are proportional means they are similar. Or if two sides and one included angle of one triangle similar to the corresponding two sides and another included angle of the same other triangle, then the triangles are similar. Recapping that, we'll continue the question solutions here. 11th one. See, in the figure, whatever they are given here, I'm not drawing the figure. Is okay, let me draw that. Then we'll start with the question. ABD, and this is 90 degree, and P is produced here, and it is made E here. This is also 90, and we call it as E. This will be F. Okay. E is the point on CB produced, and isosceles triangle ABC. Remember, ABC is isosceles triangle means this is given with AB equal to AC. That is, sorry, not angle. I'm sorry. I made angles equal. With AB equal to AC means AB equal to AC is given. They are perpendiculars. AD perpendicular to BC, EF perpendicular to AC. We have to prove ABD, ECF are similar. Very simple it is. Why simple? See, I'll explain first and I will start. What is ABD? ABD, we have D 90 degree. EFC, we have F 90 degree. So one angle we got. Another one means one angle we got means either we use 3 by A or 2A or SAS. SAS we cannot use because sides proportionality they are not given. Another angle we have to find. For that they have given the clue AB and AC are equal. So AB opposite angle is C, inequality. AC opposite angle is B. Therefore, in triangle ABD, B angle is equal to in triangle EFC, C angle. We are done. Okay. Once we write, we'll have clear understanding. Let's check. In triangle given, in triangle ABC, AB equal to AC. When AB means it's opposite angle C, AC means it's opposite angle B. We write the equal, that is inequality angles opposite to equal sides are equal. Okay. Also they have given AD perpendicular to BC and EF perpendicular to AC. To prove, when they say perpendicular, it means 90 degree, the point of intersection, either sides. To prove, just copy it from the question. ABD similar to triangle ECF. Proof, you pick the same and say in triangle ABD and triangle ECF. See, even if you don't know how to solve this, if you just write this much, you get 1 marks. Okay. What is proof? Just observe, as I said, in ABD and EFC, what is common angle? Common angle will not come. 90 degree will come, right? ABD we have ADB is 90. ADB means EFC will be 90. EFC will be each 90. Okay. This we call it as 1. Okay. In ADB, B angle is there. In EFC, C angle is there. So CB is equal. So I can say here B equal to C from 1. We are done. Two similarity means AA criteria has come. We are done with the question. ABD similar to ECF by AA similarity. Okay. Clear? Hence proved. We'll move to the next question. 12th one, quickly. What is 12th one says is there's no figure. Sides AB and BC and median AD of a triangle ABC are respectively proportional to the PQ, QR and median PM of PQR. So you have to draw two triangles here, ABC and PQR. First draw triangle, then come back to the question. ABC, PQR. So AB and BC and AD, you have to draw median here. Means this should be equal. Here PM is a median. PM, what are the medians? AD. These are all again equal. Okay. Now PM, so that ABC and PQ are equal, similar. We'll write that. Given, what is given? AB by PQ, BC by QR, AD by PM. If you observe the question, you will get this ratio. AB, BC, AD are proportional to PQ, QR, PM. Okay, this is given. And AD, PM are medians, right? AD and PM are medians. Okay. When they're medians means the median landing side will have equal parts. Okay. To prove, we write triangle ABC similar to triangle PQR. Proof. See, I'll give the concept knowledge here. To prove ABC and PQR as similar, either we need triple A. Here AA won't come. Sides proportional. All three sides should be proportional. Out of that, if you observe, already we have two sides proportional. Only third side we want, or one of the angle, because SAS might come or SSS might come. Since ADPM are equal, proportional, ADPM, we have to prove ABD and QPM are proportional. Therefore, B and Q we get as by corresponding angles of the similar triangles equal. We lose that knowledge. Understood? We have to make now ABD and PQM. Okay, I'll take that. In triangle ABD and triangle PQM, what we get? Okay, before that we'll just say, before that we'll say what is given. Just check out. AB by PQ equal to BC by QR equal to AD by PM. BC by QR will just alter it, that is AB by PQ. BC is, I'll say, half BC, similarly half QR. When you do same operation to numerator denominator, LHS or HS, it will not change the values. For our solutions, we can do that. So AD by PM. Okay. Now half BC, I'll say AB by PQ. Half BC, I'll take BD. Half QR, I'll take QM. AD by PM. This is given. So this we call it as 1. So we come back. In triangle ABD and triangle PQM, see, check out, all the three ratios are equal. Just copy it. AB by PQ, BD by QM, AD by PM. We just got from 1. Therefore, triangle ABD similar to triangle PQM by SSS similarity. Understood? How do you prove SSS similarity? Means half BC, half QR. I'll take the BD part, because ABD you can also take CD. That time it will come ADC and PMR as similar triangle. So with this similarity, we can take out other remaining parts as equal, right? Just like congruency, we take B equal to Q. B equal to Q, we write the reason, corresponding angles of similar triangles. Therefore, what we want now, ABC and triangle PQR, we have already two sets equal, right? Corresponding, proportional. AB by PQ equal to BC by QR. This is given. Okay. And B equal to Q, we just proved. Just proved above. Therefore, triangle ABC similar to triangle PQR, hence proved by SAS similarity. The concept is two ratios already available in the main triangles, what they wanted us to prove similar. We need one more criteria, either A or another side. We choose A here because it was easy for us, and we have given AD and PM equal. So we proved ABD and QPM are similar. We proved AB and Q are equal because they are corresponding angle of the similar triangles. We used SAS to prove the main, prove ABC and PQR are similar. This is the last question, 13th one. Mark this as important. Okay. Let's see. D is a point on the side BC of a triangle ABC such that ADC BAC are equal. So there is no figure given. We just draw the figure here. Okay. D is a point on the BC, right? So D is the point. I'll say BC here, A here, AD we join it. Such that ADC means this ADC is equal to BAC. This whole is given. We have to prove CA square is equal to CA square is equal to CD into CB. Let's see. Given. What is given? Just write what is the angle given. ADC equal to BAC. To prove, pick the proof, CA square is equal to CB into CD. Basically, you have to prove ABD and BAC similar triangles. Okay. Let's see. In triangles, ADC, how do we pick? Because there are three triangles here. Which one to pick? You have to understand CA square is CA into CA, CA by CD, CA by CB equal to CD by CA. So this part is very important. What is to be proved? That's why I said it's important question. In triangle ADC and triangle BAC. See, whatever angle they have given, I'm picking those triangles. That's a clue. In ADC and BAC, they're given one angle equal same. That is, just write it given. Okay. Observe ADC and BAC, we get C angle common. Therefore, C equal to C, common angle. Therefore, similar. Very easy. But to get only this required part, we cannot get that. So we just write all three ratios. Therefore, AD by BA equal to AC by BC equal to DC by C. AD by AB, BA equal to AC by BC equal to what is left? DC by AC. DC by AC. If you observe three ratios, we want only two ratios. So if you consider these two ratios, the last two, AC by BC equal to DC by AC, we get AC square, right? Therefore, you just write what is to be proved. Therefore, CA square is equal to CB into CD and proved. When you wrote this part, you write the reason, corresponding parts of similar triangles. Because we proved similarity by quickly by given angle and C is the common. You check out ADC and BAC, C comes common. Then you pick the ratios, all three ratios. Don't try to write what is required only. We cannot write that quickly unless you have practice. So once you write three ratios, pick the two ratios so that you get the required condition. Okay. This completes the 13th one, and 13th one is very important. Thank you.